Welcome to the DIY Honda Garage channel. The DTC P2175 is an indicator that there is low airflow detected in the throttle actuator control system of the Honda CRV, specifically from the model years 2017 to 2022. This code usually arises from issues within the powertrain control module, PCM, which manages various aspects of the engine and throttle operation. When low airflow is detected, it can impact the vehicle's performance, leading to suboptimal engine operation and reaction to acceleration. The throttle actuator control system is crucial as it regulates how much air enters the engine, directly affecting power, efficiency, and emissions. Understanding this DTC is essential for identifying issues within the PGM-FI, programmable fuel injection system, that could be causing this alert, and ensuring that the vehicle operates efficiently. The DTC P2175 points to the throttle actuator control system as the source of low airflow detection, which is critical for the proper function of the vehicle's engine. The main components involved include the throttle body and the powertrain control module, PCM. The throttle body is located between the air intake and the engine, where it regulates airflow based on driver input via the accelerator pedal. The PCM uses data from various sensors, including the mass airflow (MAF) sensor and intake air temperature (IAT) sensor, to determine how much air to allow into the engine for optimal performance. A failure or malfunction in any of these components can lead to decreased engine efficiency and potentially trigger the P2175 code. Visual checks on the intake air duct and air cleaner housing can help in identifying issues at initial stages of the troubleshooting process. Several factors can lead to the P2175 code being triggered. First, there may be poor connections within the intake air ducts, which can cause a loss of airflow and impact engine performance. Blockages in the intake system can restrict airflow to the engine, which can also result in this error code. Additionally, dirty air cleaner elements can become clogged with dirt and debris, preventing adequate airflow from reaching the throttle body. These issues can lead to complications such as decreased engine power, increased fuel consumption, or even stalling. As a result, bringing the vehicle in for a thorough visual inspection of these components as part of the diagnostic process can be critical. The symptoms associated with DTC P2175 can vary, but generally include decreased engine performance, unresponsive acceleration, and illumination of the check engine light. When there is low airflow to the engine, the vehicle may struggle to accelerate properly or exhibit power loss when climbing hills or during rapid acceleration. Drivers may experience a lack of responsiveness from the throttle, making it difficult to maintain speed or respond efficiently to gas pedal input. The engine management system detects these performance issues and registers the P2175 code, causing the check engine light to activate as a warning. These symptoms collectively indicate that the throttle actuator control system is not functioning as intended, potentially requiring immediate attention from a qualified technician. The first troubleshooting step involves turning the vehicle to the on mode and then connecting the Honda Diagnostic System (HDS) to check for any pending or confirmed DTCs. It is essential to identify whether there are any additional DTCs present alongside P2175. If other DTCs are found, troubleshooting them should take precedence, as they may provide clues to the root cause of the problem. If there are no other DTCs visible, you can proceed to the next steps in the diagnostics. This systematic approach ensures that you cover all potential issues and do not overlook other faults which may be contributing to the performance problem. Leveraging diagnostic tools like the HDS is crucial in ensuring an accurate assessment of the vehicle's health. In the second troubleshooting step, you need to turn the vehicle to the off mode and visually check the intake air duct for any poor connections or blockages. The intake air duct serves as the pathway for air entering the engine. Any disruptions can severely impact performance. Inspecting for any signs of physical damage, loose connections, or debris is essential at this stage. If everything appears satisfactory, you will advance to the next step. However, if you find any issues, reconnecting or repairing the duct or replacing it as needed is mandatory. Ensuring that the intake pathway is unobstructed and secure is a crucial step in rectifying the P2175 DTC and ensuring proper vehicle function. Step 3 involves checking the air cleaner housing for blockages or poor connections. The air cleaner housing is vital as it houses the air filter, which prevents contaminants from entering the engine. A visual inspection should be performed to ensure that the housing is intact and there are no signs of obstruction. If you detect any issues, replacing the air cleaner housing will be necessary to restore proper airflow. On the other hand, if the air cleaner housing appears to be in good shape, you will proceed to the next step in the troubleshooting process. Maintaining air intake quality is key for engine performance and efficiency, particularly for a modern vehicle such as the Honda CRV. The fourth step focuses on inspecting the air cleaner element itself for any dirt or debris that could obstruct airflow. The air cleaner element plays a pivotal role in filtering the incoming air before it reaches the engine. If the element is dirty or clogged, it can severely limit airflow, contributing to the P2175 code. A thorough inspection should reveal if it requires cleaning or replacement. If dirt is found, replacement ensures that clean air enters the engine, optimally supporting combustion. If the air cleaner element is found to be clean, the troubleshooting will proceed to the next steps, allowing for a systematic assessment of all potential contributing factors to the low airflow condition. In the fifth step, begin by turning the vehicle to the on mode and allowing the engine to cool down until the engine coolant temperature ECT sensor 1 reads 122 degrees Fahrenheit, 50 Celsius or less. This ensures accurate readings during diagnostics. Next, clear the DTC using the HDS and start the engine, letting it idle for over 10 seconds. It is now crucial to monitor the OBD onboard diagnostic status of DTC P2175 using the HDS. If the HDS indicates failed, this confirms that the issue persists. In contrast, a past reading suggests an intermittent fault, warranting checks for connections at various sensors, including the throttle body, MAF sensor, and the PCM. Monitoring the DTC status at this stage is vital for understanding if the issue is ongoing or temporary, guiding further diagnostic steps. Step 6 involves conducting a throttle body test by selecting the ETCS, Electronic Throttle Control System, TAC, Throttle Actuator Control, test from the Function Test menu on the HDS. This test will determine if the throttle actuator control valve is functioning normally. If the readings confirm normal operation, you will proceed to the next diagnostic step. However, if the throttle body is indicated as not functioning correctly, it will need to be replaced. The throttle body is a critical component as it directly affects the airflow rate that is essential for proper engine performance. Ensuring its functionality is particularly important in isolation for resolving the P2175 code. For Step 7, start by turning the vehicle to the off mode before disconnecting the intake air duct from the throttle body. This is essential to allow for an unobstructed view of the throttle bore area, which is where the throttle valve operates. Inspect thoroughly for signs of dirt, carbon buildup, or physical damage within the throttle bore. These can impact airflow and the functioning of the throttle actuator. If you discover significant dirt or carbon, cleaning the throttle body is advised to restore functionality. However, If there is noticeable damage, replacing the throttle body would be the appropriate action to ensure optimal operation. This step is essential, as a clean and intact throttle body is crucial for engine performance and response. In Step 8, turn the vehicle to the on mode and compare the values of the MAP, Manifold Absolute Pressure, sensor as displayed in the HDS against established baselines. A key part of this process is determining if the difference in values is 26.7 kilopascal, 7.9 inches, or 200 millimeters mercury, or more, which indicates an issue with the MAP sensor. If the difference is significant, replacing the MAP sensor is necessary to ensure accurate pressure readings, which are vital for proper engine functioning. Monitoring this parameter helps in diagnosing the sensor's performance, which is critical for maintaining balanced air-fuel ratios, ensuring optimal engine performance. Recognizing faults in the MAP sensor at this stage can prevent further complications within the throttle actuator control system. Step 9 involves recording the value of the MAP sensor and then starting the engine to allow it to idle. You will check the MAP sensor values displayed in the HDS to see if they change by 0.67 kilopascal, 0.2 inches ek, or 5 millimeters inches ek, or more during this process. If the values do not change significantly during idling, the MAP sensor may be faulty and needs replacement. This check is key because the MAP sensor's performance directly affects the engine's air management system, especially in ensuring an adequate air-fuel mixture. Understanding how the sensor reactively changes during engine operation helps confirm its health and functionality necessary for efficient engine performance. Step 10 requires turning the vehicle to the off mode and then back to on to compare the TC turbocharger boost pressure readings with those of the barometric sensor in the HDS. This comparison is necessary to ascertain if the difference is 26.7 kilopascal, 7.9 inches, or 200 millimeters ng, or larger. If the readings show a substantial difference, this indicates a problem with the turbocharger boost sensor, which will need replacing. The turbocharger boost sensor is significant in optimizing engine performance, especially in turbocharged systems where managing air intake is crucial. Diagnosing this sensor ensures reliable performance and efficiency, as discrepancies might indicate improper engine load and boost pressure management. In Step 11, you will record the TC boost pressure in the HDS before starting the engine. The next steps involve holding the engine at 3,000 RPM without load until the radiator fan activates, followed by allowing it to idle. Afterward, increase to 4,500 RPM without load and check the TC boost pressure again. If the pressure does not change by 0.67 kilopascal, 0.2 inch nig, or 5 millimeters inchig or more during this procedure, it suggests that the turbocharger boost sensor needs replacement. This performance check is critical, since accurate readings are vital for controlled boost pressure management, directly affecting performance and fuel efficiency. Identifying sensor faults at this stage is important to prevent further performance issues. Step 12 involves holding the engine speed at 3,000 RPM for testing, while monitoring the MAF mass airflow sensor. During this process, you should check whether the MAF sensor readings fall within the threshold range of 4.1 to 5.7 grams per second. If the current conditions do not match the specified threshold, replacing the MAF sensor or IAT sensor 1 is necessary for restoring proper engine function. The MAF sensor is pivotal as it measures incoming airflow, which is essential for the engine to optimize the air-fuel mix. A malfunctioning sensor can lead to incorrect fuel delivery, resulting in poor engine operation. Ensuring that the MAF sensor readings are accurate is critical to maintaining vehicle performance. In the final troubleshooting step, turn the vehicle to the off mode and allow the engine to cool to ambient temperature. You'll then need to note the ambient temperature and turn the vehicle back on to quickly check the IAT, intake air temperature sensor values using the HDS. Compare the current value of the IAT sensor with the ambient temperature. A difference of 5.4 degrees Fahrenheit, 3 degrees Celsius or more indicates a potential fault requiring MAF IAT sensor replacement. The IAT sensor measures the temperature of the air entering the engine, playing a critical role in calculating air density and ensuring optimal engine performance. A failing IAT sensor can impact fuel efficiency and engine behavior, making this check a crucial endpoint in addressing the DTC P2175. Once all the necessary repairs have been completed, the final repair verification process begins with a recheck of the DTC status using the HDS. This is essential to confirm whether the P2175 code has been successfully cleared and that no additional DTCs have emerged. It is highly recommended to conduct a test drive under varied driving conditions to validate that the issue has been resolved and the vehicle is performing optimally. Confirming repair effectiveness ensures that the solutions implemented were accurate and that the vehicle is operating without any airflow problems in the throttle actuator control system. A successful outcome not only restores engine performance, but also helps in preventing future issues related to the air intake system, thereby improving overall vehicle reliability. To prevent future occurrences of DTC P2175, implementing a preventive maintenance schedule is advisable. Regularly checking the air filter and replacing it as necessary helps maintain optimal air intake, promoting efficient engine performance. Additionally, inspecting the intake system for any loose connections or blockages can prevent issues from arising. Furthermore, periodic cleaning of the throttle body can help in removing any carbon deposits or dirt that could restrict airflow. Keeping these components in good shape proactively reduces the risk of low airflow issues and enhances the longevity of the vehicle. Prevention is always more efficient and cost-effective compared to repairs, particularly concerning air management systems that are essential for maintaining engine health. In conclusion, the DTC P2175 highlights the importance of a well-functioning throttle actuator control system for a Honda CRV. Thorough diagnostics are crucial in identifying root causes and rectifying issues related to low airflow in the engine. By systematically assessing the various components and sensors involved, from the intake air duct to the MAF and IAT sensors, carrying out precise troubleshooting can lead to effective repairs. Additionally, implementing preventive maintenance measures ensures ongoing vehicle efficiency and reduces the likelihood of recurring issues. Understanding the function and significance of each component in the air intake system is key in maintaining optimal vehicle performance and longevity. Please like and subscribe to the channel. See you next time.